Welcome to a journey beyond time, beyond the ordinary rhythms of our everyday world. Tonight, we travel together to the roof of the earth, to a place where stone meets sky, where ancient peaks hold secrets written in ice and rock across millions upon millions of years. The Himalayas. Even the name feels like a whisper, a breath of mountain air, carrying stories older than human memory. These mountains stretch across the clouds, silent sentinels between earth and heaven, their snow-crowned summits glowing softly in the light of distant stars. They are not merely landmarks on a map, but living chronicles of our planet's deepest mysteries. As you settle into this moment, allow yourself to sink deeper into comfort. Feel the weight of your body supported, completely, safely. Let your breathing slow, natural, effortless, like the patient rhythm of stone being shaped by wind and water. Tonight, we'll wander together through these ancient ranges, discovering 100 gentle truths, 100 whispers from the mountains. Each fact a stepping stone, leading you deeper into tranquility, into rest. We'll explore how these giants were born, how they breathe with glaciers and rivers, how life finds its way in the thinnest air, and how humans have walked these sacred paths for thousands of years. But there is no hurry here, no urgency, only the slow, eternal pace of mountains, rising, resting, simply being. So close your eyes if you wish, or let them rest softly, half open, gazing at nothing in particular. The Himalayas are patient. They have waited 50 million years. They will wait for you. Let us begin our journey into the heart of these timeless peaks. Let us begin at the very beginning, long before these mountains touched the sky. Imagine, if you will, our planet as it was 50 million years ago. The world looked different then, felt different. The continents themselves were wanderers, drifting slowly, patiently across the face of the earth. And there, in the vast southern ocean, floated a piece of land we now call the Indian Plate, a massive fragment of the Earth's crust, moving northward, steadily, inexorably, toward another giant, the Eurasian Plate. This is how the Himalayas were born, not in fire, not in sudden violence, but in the slow, patient, inevitable embrace of two ancient lands, colliding, merging, rising together toward the heavens. 50 million years. It's almost impossible for our minds to hold such vastness of time. And yet, the mountains remember. Every fold in their stone, every peak reaching skyward is a memory of that meeting, that collision that changed the world. And here is something remarkable, something that invites us into even deeper wonder. This collision, this ancient meeting, is not finished. Even now, as you rest here, as your breathing slows and deepens, the Indian Plate continues its journey northward, moving at about 4 to 5 centimeters each year, the width of your palm perhaps, each and every year, pushing, pressing, rising. The Himalayas are still being born, still growing, still reaching upward. They are not frozen monuments to the past. They are living geology, breathing stone, rising even as we sleep. Mount Everest itself, that crown jewel of the earth, grows approximately 4 millimeters taller with each passing year. 4 tiny millimeters, the thickness of a few coins stacked together. Yet over centuries, over millennia, these small increments build cathedrals of stone that pierce the clouds. Nothing in nature hurries, and yet nothing stops. The Himalayas are young, surprisingly young. In the vast timeline of our ancient Earth, They are newcomers, the youngest major mountain range our planet has created. Where other ranges have weathered and worn down over hundreds of millions of years, the Himalayas are still in their youth, still energetic, still rising with the enthusiasm of new creation. And yet, even in their youth, they tower above all others. Now, let your mind drift back even further, back beyond 50 million years, back to a time when there were no mountains here at all. Where Mount Everest now stands, where prayer flags flutter in thin air, there was once only water. An ancient ocean called the Tethys stretched across this region, warm, shallow, teeming with life. Creatures swam here, lived here, died here, their shells and bones drifting slowly down, down, down to the ocean floor, layer upon layer, age upon age. And we know this is true because those ancient travelers, those sea creatures from an ocean that vanished, have left us proof. High on Himalayan peaks, where the air is so thin that breathing becomes a meditation in itself, climbers have discovered something extraordinary: fossils. The preserved remains of ancient sea creatures, ammonites, crinoids, marine life from a world beneath the waves. These fossils, resting now among the highest points on Earth, are gentle reminders, whispers from the deep past. They tell us that what is high was once low, what is mountain was once ocean. Everything transforms, everything changes, given enough time. Many of the rocks that form these magnificent peaks are sedimentary, meaning they were formed from sediment, from the compressed remains of that ancient seabed. Layer upon layer of sand and silt and the tiny shells of forgotten creatures, all pressed together over countless ages, hardened into stone, and then lifted thousands of meters into the sky. The ocean floor became the roof of the world. As the two great plates met and merged, the immense pressure created something beautiful. The rocks didn't simply break, they folded. Like fabric being pushed from both sides, the Earth's crust bent and curved and rippled, creating the complex folds and dramatic peaks we see today. This is why the Himalayas are not volcanic mountains. Unlike the Andes of South America, born from fire and molten rock, the Himalayas were shaped by pressure, by the patient force of continents embracing. No eruptions here, no lava flows, just stone, yielding slowly, bending rather than breaking, rising in great waves of rock. Let's consider the vastness of this range, the sheer scope of what was created. The Himalayas stretch over 2,400 kilometers. That's 1,500 miles, a distance you could walk for months and never reach the end of. From west to east, these mountains form a barrier, a wall, a boundary between worlds. They span 5 countries: India, Nepal, Bhutan, China, and Pakistan. Each nation cradling a portion of this magnificent range, each culture shaped by living in the shadow of these peaks, looking up, always up, to stone and snow and sky. Within this vast range, more than 100 individual peaks rise higher than 7,200 meters, more than 100 mountains, each one higher than any peak in Europe or North America, each one tall enough to create its own weather, to catch clouds like a shepherd catches sheep. This is Earth's highest concentration of extreme altitude mountains. Nowhere else on our planet do so many giants gather together. Nowhere else does the land reach so persistently towards space. It's as if the Earth, in this one place, decided to show us what is possible, to demonstrate that even the solid ground beneath our feet, given time, given pressure, given the patient work of geological forces, can rise to touch the stars. As you rest here, breathing slowly, naturally, consider what these mountains teach us about patience, about transformation, about the power of small movements repeated over vast stretches of time. 4 millimeters a year, 5 centimeters a year. These seem like nothing, and yet they built the highest peaks on Earth. What was once ocean floor now stands above the clouds. What seems permanent is actually dancing, slowly, gracefully, in the great ballet of geological time. The Himalayas remind us that change is constant, that growth takes time, that even the mightiest structures in our world were built gradually, steadily, one tiny increment at a time. So as your body grows heavier, more relaxed, sinking deeper into rest, imagine yourself like these mountains, moving, growing, changing, but so slowly, so gently that you need not hurry, need not rush. You are part of the same patient earth, the same geological dance. The mountains do not worry about their growth. They simply rise, naturally, inevitably, in their own perfect time. And so can you. Rest without effort. Change without struggle. Simply be like the mountains, ancient and young at once, still and moving, permanent and transforming. The Himalayas know both who they were and who they are becoming. These mountains rose from the ocean. Now let us explore what they hold within, the frozen rivers, the vast systems of ice that sculpt their faces and feed the world below. Now let us turn our attention upward to the peaks themselves, to the crown jewels of this ancient range, the highest points our planet has to offer. At the very summit of them all stands Mount Everest, rising 8,848.86 meters above the sea. This is the highest point on Earth, the place where our world reaches closest to the stars. Everest, known to the Tibetan people as Chomolungma, goddess mother of the world, and to the Nepali as Sagarmatha, forehead of the sky. It stands there, patient, eternal, wrapped in ice and cloud, waiting. When you stand at sea level and look up at an airplane flying overhead, Everest rises nearly that high, and then higher still. Its summit exists in a realm where the air holds only a third of the oxygen we breathe down here, where temperatures plunge to 60 degrees below zero, where wind screams across the ridges with the force of a hurricane. And yet, despite its fame, Everest is not the most dangerous mountain to climb. That distinction belongs to its neighbor, K2, the second highest peak on Earth. K2 stands at 8,611 meters, only 237 meters shorter than Everest, and yet, in the minds of mountaineers, it looms even larger. Its slopes are steeper, its weather more unpredictable, its challenges more severe. For every 4 climbers who reach its summit, 1 does not return. K2 asks more of those who approach it. It is less forgiving, more remote, a mountain that demands not just courage, but humility. There's another giant worth knowing, Kangchenjunga, the third highest mountain, standing at 8,586 meters. For many years, before modern surveying techniques revealed the truth, people believed Kangchenjunga was the tallest mountain in the world. Imagine that moment of discovery, when measurements showed that there were higher peaks still, that the world held greater heights than anyone had imagined. Kangchenjunga. Its name means the 5 treasures of snow, named for its 5 distinct peaks, each one a repository of ice, of mystery, of the sacred. Even today, climbers stop a few feet short of the true summit out of respect for local beliefs that the very top should remain untouched, inviolate, a place for the divine alone. Here is something remarkable about these Himalayas, something that speaks to their extraordinary nature. Of all the 14 mountains on Earth that rise above 8,000 meters, 13 of these giants are found here in the Himalayas. Only one, K2's neighbor, lies just outside in the nearby Karakoram range. 13 of the 14 highest points on our entire planet gathered here in this one magnificent arc of stone and ice. No other mountain range even comes close. The Himalayas don't just have the highest peak, they have nearly all of them, a concentration of extreme altitude found nowhere else on Earth. But the Himalayas are not just about height, they are about dramatic interplay between high and low, between peak and valley. Just kilometers away from these towering summits, deep valleys plunge downward. Some of these valleys drop so far, so steeply, that they are deeper than the Grand Canyon, that iconic gorge carved by the Colorado River over millions of years. The Kali Gandaki Gorge, for instance, cuts between two 8,000-meter peaks, creating one of the deepest valleys on Earth. Standing at the bottom and looking up, you would see walls of rock and ice rising more than 6,000 meters on either side, a vertical world where depth and height exist in constant dialogue. These mountains form something more than just a collection of peaks. Together, they create a massive natural wall, a barrier between two different worlds, between South Asia and Central Asia. For thousands of years, this wall has shaped human history, determined where people could travel, influenced which cultures could meet and which remained separate. Empires rose and fell on either side, never quite bridging this stone divide. Even weather respects this boundary. The monsoons from the south crash against these peaks and release their rain, leaving the north in rain shadow, creating the high deserts of Tibet. The mountains decide who gets water, who gets warmth, who lives in jungle, and who lives in desert. A wall built not by human hands, but by the patient collision of continents. The shapes of these peaks, their sharp ridges and dramatic faces, tell a story of two competing forces, uplift and erosion, creation and destruction, working simultaneously. As the mountains rise rapidly, pushed upward by those tectonic plates we spoke of earlier, wind and water and ice work just as rapidly to wear them down. This creates the sharp ridges, the knife-edge arêtes, the dramatic faces that make these peaks so visually striking. If the mountains rose slowly, erosion would soften their features, creating gentle, rounded summits. But here, uplift happens so quickly that erosion cannot keep pace, and so the peaks remain sharp, angular, almost impossibly steep, as if freshly carved. This steepness, combined with the geology of the range, creates its own dangers. Landslides are common here, a consequence of steep slopes meeting unstable rock, of heavy monsoon rains saturating the earth, of ice and frost breaking stone apart. Entire hillsides can move without warning. Valleys that were passable one day become blocked the next. Rivers that flowed freely find themselves dammed by fallen rock. The mountains are not still. They shift, settle, collapse, reshape themselves season by season, year by year. And beneath it all, a deeper restlessness. Earthquakes, frequent and sometimes devastating, shake this region. This is the inevitable consequence of those tectonic plates still pushing, still colliding, still creating enormous stress deep within the Earth's crust. That stress must be released, and it releases suddenly, violently, as the ground shakes and buildings fall and mountains themselves are reshaped. The same forces that built these peaks continue to test them, to shake them, to remind us that they are not finished growing, not finished changing. The Himalayas are alive, in the geological sense, still moving, still dangerous, still unpredictable, a landscape in constant conversation with the forces that created it. As you breathe here, slowly, deeply, consider these contrasts, these peaks that rise to impossible heights and valleys that plunge to extraordinary depths. This stone that seems so permanent and yet moves, shifts, grows, falls. The Himalayas teach us about extremes, about how the highest highs and lowest lows can exist side by side, about how strength and vulnerability are not opposites, but companions. Even the mightiest mountain is still shaped by wind, still carved by water, still moved by forces beyond its control. And perhaps, in that, there is permission for us to be the same, strong and vulnerable, permanent and changing, reaching upward while also acknowledging the valleys within us. These peaks hold something more than stone. They cradle rivers of ice, ancient glaciers that flow like frozen time. Let us explore these now, the ice systems that crown the Himalayas. Now, we turn our attention to something extraordinary, something that transforms these stone giants into givers of life: ice. Vast rivers of ice flowing slowly down the mountainsides, carving valleys, shaping stone, holding water in frozen suspension, waiting. The Himalayas contain the largest mass of ice on Earth outside the polar regions. More ice than anywhere else except Antarctica and Greenland. Frozen water locked in glaciers spread across these peaks like a vast, patient reservoir. Imagine that! In a place where no ocean exists for thousands of kilometers, there is more frozen water than almost anywhere on the planet. More than 15,000 glaciers call these mountains home. 15,000 rivers of ice. Some small, tucked into shadowed valleys, others massive, stretching for dozens of kilometers, grinding their way slowly, inexorably downward. Each one unique, each one ancient, each one carrying within it the accumulated snowfall of centuries, compressed, transformed, turned from soft flakes into blue ice harder than most stone. These are not static things. Despite their appearance, despite their seeming permanence, glaciers flow. Slowly, so slowly you could never see it with your eyes. But they move, creep, slide downhill under their own tremendous weight, reshaping the land beneath them as they go. And here is why these glaciers matter, why they are more than just beautiful frozen landscapes to admire. These glaciers feed the major rivers of Asia. The Ganges, the Brahmaputra, the Indus, the Yangtze, the Mekong, the Yellow River. Some of the greatest rivers on Earth, sustaining billions of people, begin here as meltwater from Himalayan ice. The glaciers are natural freshwater reservoirs, vast banks of frozen water holding precipitation from winter snows and summer monsoons, storing it, preserving it, releasing it slowly throughout the year. This rhythm is essential. During the dry seasons, when rain does not fall, when crops would wither and rivers would run dry, glacial melt sustains the flow. The ice melts faster in summer heat, sending water downstream exactly when it's needed most. It's a perfect system, refined over thousands of years, a natural clockwork of freeze and thaw, accumulation and release, the mountains breathing water to the valleys below. For millions of people living downstream, people who may never see these peaks, who may never know the names of these glaciers, this ice is life itself. But something is changing. Many of these glaciers are retreating. Year by year, measurement by measurement, scientists observe them pulling back, shrinking, losing mass. The warming climate is shifting the balance. More melt than accumulation, more water flowing away than snow falling to replace it. Some Himalayan glaciers are shrinking faster than the global average, retreating at rates that alarm those who study them, who understand what this means for the future, for the rivers, for the people who depend on them. The ice that took centuries to accumulate is vanishing in decades. As the glaciers retreat, they leave something behind, something both beautiful and dangerous: glacial lakes. These form where ice once stood, meltwater pools and depressions behind walls of loose rock and debris that the glacier left behind. These lakes grow, filling with water, held back by nothing more than piles of unstable sediment, what scientists call moraine. Some of these lakes are stunning, turquoise jewels cradled in rocky bowls, reflecting sky and stone. But they are also fragile, precarious, dangerous. These lakes can burst suddenly, catastrophically. Perhaps an avalanche falls into the water, creating a wave. Perhaps the moraine wall, never meant to hold back so much water, simply fails. Perhaps an earthquake, one of those tectonic tremors we spoke of, shakes the dam loose. Whatever the trigger, the result is devastating. Millions of gallons of water, released in moments, racing down narrow valleys, carrying rocks and ice and debris, a wall of destruction that can travel for many kilometers, sweeping away everything in its path. Scientists have a name for these events: glacial lake outburst floods, or GLOFs. The acronym sounds clinical, technical, but the reality is terrifying. Villages destroyed, bridges washed away, fields buried, lives lost, all in the time it takes for a lake to empty. Because of this danger, because the risk grows as more glacial lakes form, scientists monitor these ice systems carefully. Satellite data, images taken from space, allow researchers to track glacier movement, to measure how quickly ice is retreating, to identify which glacial lakes are growing, which ones might be at risk of bursting. From orbit, cameras watch the slow dance of ice, recording changes invisible to the human eye, building archives of information that help predict, prepare, protect. Technology watching over ice, human ingenuity trying to understand and perhaps mitigate the consequences of a changing climate. But the satellites can only see the surface. To truly understand these glaciers, to read their history, scientists must go deeper. They drill ice cores, long cylinders of ice extracted from deep within the glacier. Each layer represents a year, a season, a moment in time when snow fell and was compressed into ice. Trapped within these layers are bubbles of ancient air, particles of dust, chemical signatures of temperature and precipitation. The ice remembers. It holds within it a record of climate, of atmosphere, of conditions that existed when that layer formed. Some of these layers are over 1,000 years old. Imagine holding a piece of ice, knowing that it fell as snow when medieval kingdoms ruled the lands below, when entirely different human stories were unfolding, and yet the ice preserved it all, waiting patiently to share its secrets. These ice cores tell scientists about past climates, help them understand how temperature and weather patterns have changed over centuries, provide context for the rapid changes happening now. The glaciers are not just water sources, they are libraries, archives of atmospheric history, written in ice and air and trace elements, waiting to be read by those who know how to listen. But the ice faces threats beyond warming temperatures alone. Black carbon, tiny particles of soot from incomplete combustion, from cooking fires, from vehicle exhaust, from industrial pollution. This dark material settles on the white surface of glaciers, and white ice reflects sunlight, bounces heat away, stays frozen. But darken that surface with black carbon, and suddenly the ice absorbs more heat, melts faster. A small change in color, creating a significant change in temperature, accelerating the retreat we're already witnessing. And there's more. Dust from distant deserts, carried on high-altitude winds, settles on the glaciers as well. The Gobi Desert, the Taklamakan, even the deserts of the Middle East send their dust on long journeys through the atmosphere, and some of it comes to rest here on these high ice fields. Like the black carbon, this dust darkens the surface, increases heat absorption, speeds melting. So the glaciers face a triple threat: rising temperatures, pollution settling from above, and dust arriving on the wind from far away.
The ice that seems so permanent, so untouchable, so removed from human activity is actually deeply connected to everything we do, everywhere on Earth.
As you rest here, breathing slowly, naturally, consider what these glaciers teach us about interconnection. Ice that forms in one place feeds rivers in another, sustains people thousands of kilometers away. Pollution from cities we'll never visit, dust from deserts we'll never see, travels through the air and affects ice on the highest mountains, which in turn affects water supplies for billions. Everything touches everything. Nothing exists in isolation. The glaciers show us this truth written in ice and water. They remind us that we are all downstream from someone and upstream from someone else, all connected in ways we rarely see, but which are no less real for being invisible. These 15,000 glaciers, holding more ice than almost anywhere on Earth, they are magnificent, essential, and vulnerable. They have been here for thousands of years, flowing, freezing, melting, following rhythms older than civilization. But those rhythms are changing now, shifting in ways that even the ice, with all its ancient patience, struggles to adapt to. The glaciers still flow, still feed the rivers, still carve the valleys, but they are also teaching us about fragility, about how even the mightiest systems can be altered, about how the future might look different from the past. And yet, they persist. Every winter, snow falls. Every cold season, ice accumulates. The glaciers continue their work, patient, enduring, doing what they have always done. They teach us about resilience too, about continuing despite change, about adapting to new conditions, about the importance of what we do now, in this moment, to preserve what we can while we can. The ice holds memories of the past and hints of the future, and in the present moment, it simply flows, slowly, inevitably, downward toward the valleys, toward the rivers, toward life. Let yourself rest now, like snow settling on a glacier, gently accumulating, layer upon layer, building slowly, patiently. No hurry, no rush, just the natural rhythm of settling, of becoming, of being. From ice, we turn to water. From frozen reservoirs to flowing rivers, let us follow the melt downstream and discover how these mountains give life to half the world. The ice melts and becomes something else, water, flowing, seeking, finding its way downward, pulled by gravity, shaped by stone, becoming rivers that will journey thousands of kilometers from the highest peaks to the lowest seas. The Himalayas have a name among scientists and scholars, a name that captures their essential role in the rhythm of life across an entire continent. They are called the Tower of Asia, a tower that stores water as ice and snow, then releases it gradually, steadily, feeding the lands below, sustaining life, enabling civilization. 10 major rivers, some of the mightiest on Earth, begin their journeys here, born from glacial melt and mountain springs, gathering strength as they descend. The Indus, flowing west through Pakistan, carving one of the deepest gorges on the planet before spreading across desert plains. The Ganges, sacred river, mother river, winding through India, carrying not just water, but stories, faith, the ashes of ancestors, the hopes of millions. The Brahmaputra, beginning in Tibet, curving through the eastern Himalayas, one of the few major rivers that flows from east to west before turning south through Bangladesh.
The Yangtze, longest river in Asia, beginning on the Tibetan Plateau, flowing across China, connecting the high mountains to the Pacific Ocean. And others, the Mekong, the Yellow River, the Salween, each one a lifeline, each one born in these mountains.
Here is the scale of what these rivers mean, the vastness of their importance. Over 1,600,000,000 people, more than 1 in 5 humans alive today, rely on these Himalayan river systems for their water. For drinking, for crops, for livestock, for industry, for washing, for cooking, for survival. These rivers define where cities can exist, where farms can flourish, where life can thrive in regions that would otherwise be desert. The water that begins as snow on a remote Himalayan peak might end up in a rice paddy in Vietnam, or a glass in Shanghai, or irrigating wheat fields in Punjab. The mountains and the billions of people downstream are connected, intimately, inevitably, through water. The rhythm of these rivers is shaped by 2 great forces working together. First, the monsoons. Every summer, warm, moist air from the Indian Ocean sweeps northward. Meeting the Himalayan wall, the air rises, cools, releases its moisture as rain. Torrential rain, weeks of it, drumming on leaves and stone, filling streams, swelling rivers. The mountains capture this rain, channel it, transform scattered droplets into organized flow. The topography itself, the valleys and slopes we spoke of earlier, acts like a vast plumbing system, gathering water and sending it on its way. And second, snowmelt. During winter, precipitation falls as snow at high elevations, accumulating, waiting. Then, as temperatures rise in spring and summer, this snow melts, releasing water gradually over months. This is the genius of the system. Snowmelt regulates the seasonal water supply. It doesn't all arrive at once, overwhelming everything. Instead, it releases steadily, providing flow even when the monsoons have ended, maintaining rivers through the dry season. Winter's snow becomes summer's water, a perfect timing, refined over millennia. But these rivers carry more than just water. They carry sediment, silt, tiny particles of rock worn from the mountains, suspended in the flowing water, giving many Himalayan rivers their distinctive brown or gray color. The rivers transport massive amounts of this material, millions of tons every year. Erosion in the mountains becomes fertility in the plains. What the peaks lose, the valleys gain. Where these rivers slow, where they spread across flat land, the sediment settles, layer upon layer, year after year, century after century, building some of the richest agricultural soil on Earth. The floodplains formed by these rivers, the Ganges Delta, the Indus Valley, the North China Plain, these are among the most densely populated places on the planet, supporting hundreds of millions of people, growing the food that sustains nations. And it all begins with rock being slowly worn away high in the mountains, carried downstream and deposited where it can nourish life. The mountains feeding the plains, stone becoming soil, destruction becoming creation. This delicate system, this perfect balance of ice and snow and rain and flow, depends on consistency. Changes in snowfall directly affect water security for all those billions of people downstream. Less snow in winter means less meltwater in summer. Altered monsoon patterns mean unpredictable flooding or drought. The system that seemed so stable, so reliable, is actually quite sensitive to change. And change is coming. We spoke earlier of glacial retreat, of ice melting faster than it accumulates. In the short term, this might actually increase river flow. More melt means more water. But this is not sustainable. This is like spending savings faster than you earn. Eventually, the savings run out. Glacial retreat threatens long-term water stability, When the glaciers are significantly diminished, when there is less ice to melt during dry seasons, the rivers will lose their most reliable source. Their flow will become more dependent on immediate rainfall, more variable, less predictable. The buffer will be gone. The water tower will run dry. Humans have tried to manage these rivers, to control their flow, to harness their power. Dams, built across mountain rivers, create reservoirs, generate electricity, regulate flooding. And yes, they provide benefits: power for cities, irrigation for crops, protection from catastrophic floods. But dams also alter natural river ecosystems in profound ways. They block the flow of sediment. That rich soil never reaches the plains. They change water temperature, affecting the species that live in around the river. They interrupt fish migration, separating populations, breaking ancient patterns of movement that have existed for thousands of years. The river becomes something different, something more controlled, but also less alive, less connected. River biodiversity, the incredible variety of life these waterways support, depends on stable seasonal flow. Fish that spawn when water levels rise, plants that root in seasonal sandbars, insects that time their life cycles to flood and drought, birds that migrate following river corridors. All of these species evolved with certain expectations, certain rhythms they could count on. When those rhythms change, whether from climate shifts or human intervention, the ecosystem struggles to adapt. Some species thrive, others decline. The web of life, so intricate, so interdependent, begins to fray. Many of these rivers are considered sacred, holy waters where millions come to pray, to bathe, to scatter the ashes of loved ones. The Ganges most famously, but others too. The Yamuna, the Kali Gandaki, waters believed to purify, to heal, to connect the earthly and the divine. And while faith and science might seem separate, these sacred rivers have scientific importance as well. They function as ecological corridors, pathways that connect different habitats, allowing species to move, genes to flow, maintaining biodiversity across vast distances. A fish that begins life in the Himalayas might swim all the way to the ocean and back. A bird following the river might connect mountain forests to coastal wetlands. The river is a thread, stitching together ecosystems that would otherwise be isolated. Sacred and scientific importance are not contradictory. Both recognize these rivers as sources of life, as connections, as systems worthy of reverence and protection. These river systems, beginning in ice and snow high above, link the mountains to the oceans. Water that falls as snow on Everest might eventually flow into the Bay of Bengal or the Arabian Sea. Nutrients eroded from the Himalayan rocks might feed marine life thousands of kilometers away. The rivers are arteries, carrying the essence of the mountains, distributing it across the continent, connecting the highest peaks to the deepest seas. Everything flows, everything connects. The mountain and the ocean, though they seem like opposites, are part of one continuous system, one unbroken cycle of water. As you rest here, breathing slowly, effortlessly, imagine yourself like water, finding your way, naturally, without force, moving around obstacles rather than fighting them, seeking the lowest path, the easiest course, yet persistent, patient, eventually reaching where you need to go. Water doesn't struggle, it flows,
It adapts to whatever container holds it, whatever channel guides it. And yet it also shapes those channels over time, carves new paths, creates beauty through persistence.
These rivers have flowed for thousands of years, following paths carved before human history began, sustaining civilizations that rose and fell along their banks, continuing, always continuing, regardless of who depends on them or what changes around them. They are older than empires, more permanent than cities, more essential than almost anything else in the human world. And yet, they are also fragile, dependent on snow that might not fall, on glaciers that might not persist, on decisions made by people who may never see the mountains where the water begins. The Himalayas give water to Asia, freely, abundantly, a gift that asks nothing in return except perhaps awareness, appreciation, care for the systems that make such generosity possible. 1,600,000,000 people receiving water from these mountains, each drop connected to snow, to ice, to stone, to the patient work of geological time, to the perfect positioning of this range, catching monsoons, storing snow, releasing water exactly when and where it's needed. The water tower of Asia, standing, giving, sustaining. May it always flow. Let your breathing flow like water now, effortless, natural, following its own rhythm. No need to control it, just observe it, like watching a river, constant yet always changing, the same yet always new. From water, we turn to air, from rivers that flow through valleys to winds that sweep across peaks. Let us explore the atmosphere of these high places, the climate that shapes everything. We have spoken of stone and ice and water. Now let us turn our attention to something even more invisible, yet equally powerful: air. The atmosphere that moves across these peaks, swirls around these summits, rises and falls with the contours of the land. The Himalayas don't just exist within the climate, they create it, shape it, determine it for half a continent. These mountains strongly influence Asian climate in ways both obvious and subtle, in patterns that affect billions of lives, even lives lived far from any peak. Imagine cold winds from Central Asia, from the vast steppes of Mongolia, from the frozen expanses of Siberia, sweeping southward, carrying winter's chill, seeking warmer lands. But then they meet this wall, the Himalayas, standing like a barrier, a shield, blocking those cold winds from reaching South Asia. Without these mountains, the Indian subcontinent would be much colder. Winters would be harsher, growing seasons shorter. But the peaks intercept that Arctic air, force it to rise, to lose its momentum, to deposit its cold elsewhere. This creates warmer conditions for agriculture across northern India, Pakistan, Bangladesh, Nepal's southern plains. Conditions that allow multiple harvests per year, that support rice and wheat and countless other crops, that makes civilization possible in its current form. The mountains protecting the lands to the south, creating warmth through their presence. But the Himalayas don't just block winds, they also shape the monsoon, that annual rhythm we spoke of earlier when rain sweeps northward from the ocean. Here's how it works. Warm, moist air travels north from the Indian Ocean. When it meets the rising wall of the Himalayas, the air has nowhere to go but up. It rises, climbing the slopes, gaining altitude, cooling as it rises. And as air cools, it can hold less moisture, so the water vapor condenses, becomes droplets, becomes rain, torrential rain that falls on the southern slopes and valleys. This is orographic precipitation, a technical term that simply means rain caused by mountains forcing air upward. The mountains trigger heavy rainfall not through any active choice, but simply by being there, by standing in the path of moisture-laden winds, by lifting air to where it must release its water. On the other side, the northern side, something different happens. The air that rises over the peaks has lost most of its moisture on the southern slopes. By the time it descends into Tibet, it's dry, depleted, carrying little rain. This creates what scientists call a rain shadow. The Tibetan plateau receives far less rainfall than the lands to the south, not because it's farther from the ocean, but because the Himalayas stand between. And so the Himalayas help maintain the Tibetan plateau's climate, that high, cold desert, where the air is thin and the landscape stark. A completely different world just on the other side of the peaks. One mountain range creating two distinct climates, wet and green to the south, dry and austere to the north.
The snow that covers these peaks is more than just beautiful, more than just a source of meltwater. Snow cover affects regional temperature regulation in profound ways. White snow reflects sunlight, bounces it back to space before it can warm the ground. This keeps the mountains cooler, which in turn affects air temperature over a vast region. The Himalayas act like a massive air conditioner, cooling the atmosphere around them. When snow cover decreases, less light is reflected, more heat is absorbed, temperatures rise further, creating a feedback loop, a cycle that accelerates change. The snow isn't just frozen water, it's a thermostat, helping regulate temperature for much of Asia. High above these peaks, in the thin air where jet airliners cruise, powerful winds circle the Earth. These are the jet streams, rivers of air moving at hundreds of kilometers per hour, meandering around the planet, influencing weather patterns across entire hemispheres. And the Himalayas, even from the ground, influence jet stream behavior. The massive height of these mountains disrupts the normal flow of upper-level winds. The jet stream must go around or over, and in doing so, it bends, splits, changes its pattern. These changes can affect weather thousands of kilometers away. A storm in Europe, heat in China, drought in India, all potentially influenced by how air flows around these peaks. The mountains reach so high they touch systems normally far above the Earth's surface, connecting ground-level geography to global atmospheric patterns. But something concerning is happening here. The Himalayas are warming faster than the global average. While the planet as a whole heats up, these mountains are heating up even more quickly. Scientists call this elevation-dependent warming. The higher you go, the faster temperatures are rising. The reasons are complex, involving snow cover feedbacks, changes in cloud patterns, atmospheric circulation shifts, but the result is clear. The Himalayas are experiencing climate change more intensely than most places on Earth. This temperature rise affects snowfall patterns. Warmer air means precipitation that once fell as snow now falls as rain. The elevation where snow begins creeps higher up the mountains each year. Areas that reliably received snow for centuries now see rain instead. This matters enormously. Rain runs off immediately, flows away within hours or days, provides no long-term storage. But snow accumulates, waits, melts gradually, providing water for months. Reduced snowfall means reduced river recharge, less water stored naturally for the dry season, more variability, less reliability, greater risk. The change from snow to rain is not just about temperature, it's about transforming the entire water system of Asia. Within this vast range, within this single mountain system, exist countless microclimates. A microclimate is exactly what it sounds like, a small area with its own distinct climate, different from the surrounding region. In the Himalayas, you might find a warm, sheltered valley, just kilometers from a windswept, frozen ridge. A forest thick with ferns and moss, within sight of barren stone and ice. Microclimates created by elevation, by slope direction, by the way valleys channel or block wind, by whether a slope faces the sun or lives in shadow. Rainfall varies drastically within short distances here. Cherrapunji in the eastern Himalayas is one of the wettest places on Earth, receiving over 11 meters of rain per year, 40 feet of rain, an almost unimaginable deluge. But just on the other side of the ridge, rainfall might be a fraction of that amount. The mountains create these extremes, these pockets of abundance and scarcity, sometimes separated by nothing more than a single ridge, a few kilometers, yet worlds apart in the water they receive. For scientists trying to understand and predict climate, the Himalayas are crucial. Climate models, complex computer simulations that try to forecast how our atmosphere will behave, use the Himalayas as key variables. Get the Himalayas wrong, and your model fails to predict monsoons correctly, misses how heat distributes across Asia, doesn't capture how the jet stream will meander. The mountains are so influential, so central to Asian climate, that accurate climate modeling for half the planet requires accurate representation of these peaks. Every climate scientist studying Asia must reckon with these mountains.
And the atmosphere carries more than just moisture and warmth across these peaks. Atmospheric dust travels across the range as well. Dust from the deserts we mentioned earlier, from agricultural lands, from industrial areas, tiny particles lifted high into the air, riding winds that sweep across continents. Some of this dust settles on the glaciers, darkening them, as we discussed, but some travels farther, crosses the mountains entirely, affects air quality in distant valleys, influences rainfall chemistry hundreds of kilometers away. The atmosphere connects, just as water connects. Dust that begins in one place affects another. Nothing stays isolated. Everything travels, everything influences everything else. As you breathe here, slowly, naturally, consider that the air filling your lungs is part of the same atmosphere that sweeps across these peaks. Perhaps molecules in this very breath once touched those summits. Perhaps they rose over Everest, or cooled against glacial ice, or carried moisture from the distant ocean before releasing it as mountain rain. We breathe the same air as the mountains. We are connected to them through every breath, through the atmosphere we share. The Himalayas teach us that climate is not just weather happening somewhere. Climate is shaped, actively shaped, by geography, by the presence or absence of mountains, by their height and orientation, by how they force air to rise or block it from passing. The mountains don't just experience climate, they create it, regulate it, distribute it, determine who gets rain and who lives in desert, who stays warm and who endures bitter cold. And as the climate changes, the mountains change too. Less snow, warmer temperatures, shifting patterns. The relationship flows both ways. The mountains shape climate, and climate shapes mountains. But even as things change, the essential patterns remain. Air still rises over these peaks. Monsoons still bring rain, though perhaps at different intensities, different times. Cold winds still press from the north, though perhaps not as cold as before. The jet stream still meanders, influenced by this massive barrier of stone. The Himalayas continue their work, moderating, influencing, shaping, doing what they have done for millions of years, though now in a changing world, adapting slowly to new conditions. Let yourself be like the wind now, moving without resistance, flowing around obstacles, rising and falling naturally, sometimes warm, sometimes cool, always moving, always present, never forcing, simply flowing where the path leads. The wind doesn't worry about where it's going, it simply moves, responds to pressure and temperature, finds its way without thinking, without planning, just being, just flowing. The atmosphere over these mountains is invisible, yet it shapes everything visible. The forests that grow, the glaciers that persist, the rivers that flow, the people who live here, all shaped by air, by temperature, by rainfall, by wind, by the invisible patterns that the mountains create. We cannot see climate,
but we see its effects everywhere. In every tree, every stream, every pattern of life. The invisible shaping the visible, the unseen determining what can be seen. From air, we turn to life itself. From the invisible forces that shape conditions to the countless creatures that thrive within those conditions. Let us explore the biodiversity of these mountains, the rich tapestry of life that calls the Himalayas home.
We have explored stone, ice, water, air. Now we turn to the most miraculous element of all, life. Against all odds, in one of the harshest environments on Earth, life flourishes here. Not just survives, but thrives, diversifies, creates beauty and complexity that rivals anywhere on the planet. The Himalayas are recognized as one of Earth's biodiversity hotspots, a place where an extraordinary variety of species exists, many found nowhere else, many still being discovered. A treasure house of life, clinging to cliffs, rooting in thin soil, blooming in impossible places. Over 10,000 plant species call these mountains home. 10,000 different ways that life has learned to photosynthesize, to grow, to reproduce, to endure winters and summers at altitudes that would seem uninhabitable. From tiny alpine flowers no bigger than your thumbnail, to ancient rhododendron trees draped in moss, from medicinal herbs growing in rocky crevices to bamboo forests swaying in monsoon winds. Each species, a solution to the puzzle of survival, each one uniquely adapted to its particular niche, its specific combination of altitude, temperature, moisture, sunlight. Many of these plants are endemic to the region, meaning they exist here and only here, nowhere else on Earth. Evolution isolated them, the mountains themselves acting as barriers, separating populations, allowing species to develop in their own distinct directions, becoming unique. These endemic plants are precious, irreplaceable. If they disappear from these slopes, they disappear from existence entirely. There is no other population, no backup, no reserve. The Himalayas are their only home, and they are the Himalayas' unique children. What creates such diversity, such variety of life in a relatively small geographic area? Altitude. As you climb from the foothills to the highest peaks, you pass through distinct ecological zones, each one with its own climate, its own conditions, its own community of life. It's like traveling from the tropics to the Arctic, compressed into a vertical journey of just a few kilometers. At the foothills, where the mountains first rise from the plains, tropical forests exist. Warm, humid, dense with vegetation. These forests buzz with insects, echo with bird calls, shelter tigers and elephants, pythons and hornbills. The air is thick, heavy with moisture and the scent of flowering vines. Trees tower overhead, their canopies filtering sunlight into dappled patterns on the forest floor. This is the realm of abundance, where warmth and water create conditions for explosive growth, for life layered upon life. Climb higher, and the forest changes. Subtropical gives way to temperate. Oak and pine replace the tropical species. The air grows cooler, crisper. The undergrowth thins. Suddenly you can see farther through the trees. Higher still, and rhododendrons appear, their twisted trunks and branches draped with lichens and moss. In spring, they explode with blooms, red, pink, white, transforming entire mountainsides into gardens. Eventually, you reach a boundary, a line where trees can no longer grow. This is the tree line, the elevation where conditions become too harsh, too cold, too windy for woody plants to survive. Above this line, alpine meadows appear. These meadows, in summer, become carpets of wildflowers. purple primulas, yellow potentillas, blue poppies, delicate blooms that last only weeks, making the most of the brief growing season. The plants here grow low to the ground, hugging the earth, seeking shelter from wind. In a landscape that seems barren from a distance, up close reveals intricate beauty, life persisting in miniature. And even higher, where almost nothing grows, where rock and ice dominate, life still finds a way. Lichens cling to stone, mosses colonize sheltered cracks, hardy grasses wave in places where the wind briefly relents. The diversity of life across these zones is staggering, each elevation creating its own world, its own possibilities. Among the creatures that inhabit these heights, few capture the imagination like the snow leopard. Solitary, elusive, perfectly adapted to this harsh environment, the snow leopard is a flagship species for the Himalayas, meaning it represents, symbolizes, the unique character of these mountains. Their thick fur provides insulation against temperatures that plunge far below freezing. Their huge paws act like snowshoes, distributing weight across soft snow. Their long tail helps with balance on precarious ledges and wraps around their body for warmth while sleeping. Snow leopards can leap 6 times their body length, hunting blue sheep and ibex on cliffs where one misstep means death. They are ghosts of the high places, rarely seen, living at elevations where few other large predators can survive. In the eastern Himalayan forests, at lower elevations, another charismatic creature makes its home, the red panda. Despite its name, not closely related to giant pandas or to raccoons, though it resembles both, red pandas are their own unique lineage, endemic to these mountains and nearby ranges. They spend their lives in trees, feeding primarily on bamboo, moving through the canopy with surprising grace for an animal that looks so round and cuddly. Their reddish-brown fur, bushy ringed tail, and gentle disposition have made them beloved worldwide, but their wild populations are declining, threatened by habitat loss, by the gradual fragmentation of the forests they need. The skies above these mountains belong to the Himalayan mono, Nepal's national bird, and for good reason. The male is spectacularly beautiful, iridescent plumage that shifts colors in the light, blues, greens, purples, bronzes, like a living rainbow foraging on alpine slopes. They dig in the earth with their powerful beaks, searching for roots and insects. Their calls echo across valleys, a sound that has accompanied shepherds and pilgrims for thousands of years. To see a mono displaying in morning light is to witness how evolution can create beauty as well as function. All these species, from the smallest flower to the largest predator, share one remarkable characteristic. They have adapted to low oxygen levels. At high altitudes, the air is thin. Each breath contains fewer oxygen molecules than at sea level. At the elevation of Everest Base Camp, the air has only half the oxygen of sea level. For most creatures, this would be fatal, but Himalayan species have evolved solutions. Their blood carries oxygen more efficiently. Their hearts and lungs work differently. Their metabolism adjusts to function on less. Some species can slow their breathing, their heartbeat, entering states of reduced activity during the coldest months. Life finding ways to thrive even where the air itself seems insufficient. Among the plants of these mountains, many possess properties beyond their ecological roles. Medicinal plants have been harvested here for thousands of years. Traditional medicine systems, Ayurveda, Tibetan medicine, traditional Chinese medicine, all draw on Himalayan plants. Rhodiola for altitude sickness, cordyceps for energy, countless others for ailments from digestive issues to respiratory problems. Modern science now studies these plants, analyzing their chemical compounds, validating traditional knowledge, discovering new pharmaceutical possibilities. The mountains are not just beautiful, they are a pharmacy, a library of chemical solutions developed over millions of years of evolution. This incredible biodiversity, this variety of life, is not just interesting to scientists and nature lovers. Biodiversity supports ecosystem stability. Imagine an ecosystem as a tapestry. Each species is a thread. The more threads you have, the stronger the fabric. Remove too many threads, and the whole thing begins to unravel. Diverse ecosystems are resilient. When one species declines, others can fill its role, compensate, maintain the system's function. But simplified ecosystems with fewer species are fragile, vulnerable to collapse. The Himalayas' biodiversity is its strength, its insurance against change, its resilience in the face of challenges. In those alpine meadows we spoke of, those summer carpets of wildflowers, a crucial process occurs. Pollination. Bees, butterflies, flies, even some beetles move from flower to flower, carrying pollen, enabling reproduction. These pollinators thrive among alpine flowers, their populations supported by the brief abundance of nectar and pollen. Without pollinators, most of those flowers would fail to set seed. Without flowers, the pollinators would starve. Each depends on the other, a partnership millions of years old, still continuing, still essential in these high places. But this richness, this abundance of life, faces threats. Habitat loss threatens several species. As human populations grow, as development expands, as agriculture pushes higher into the mountains, wild spaces shrink. Forests are cleared for fields, meadows are grazed by livestock, corridors that once connected populations become fragmented. Species that need large territories, like snow leopards, find their ranges compressed. Plants that require specific conditions find their habitats disappearing. The pressure increases year by year. Climate change compounds these threats. As temperatures rise, species adapted to cool conditions must move higher. But eventually, there is nowhere higher to go. The mountain peak is the end of the road. But there is hope. There is action. Conservation zones protect fragile ecosystems throughout the Himalayas. National parks, wildlife reserves, protected areas. Sagarmatha National Park around Everest, Annapurna Conservation Area, Kanchenjunga National Park, and many others. These zones restrict development, limit resource extraction, provide refuges where wildlife can exist with minimal human interference. Local communities often participate in conservation, acting as stewards, balancing their needs with protection of the ecosystems they depend on. It's not perfect. Challenges remain. Poaching still occurs, illegal logging continues. But the protected areas represent commitment, recognition that these ecosystems, these species, have value beyond immediate human use. As you rest here, breathing slowly, effortlessly, consider the miracle of adaptation. Every species in the Himalayas is perfectly suited to its niche, each one a success story, a lineage that survived, that found its way, that solved the puzzle of existence in a challenging place. The snow leopard's thick fur, the red panda's bamboo diet, the alpine flower's brief bloom, the monal's iridescent feathers. Each one a testament to evolution's creativity, to life's persistence, to the power of adaptation over deep time. We are part of this same story. We too are adapted. We too evolved in response to challenges. We too carry within us the solutions developed by our ancestors. And we too must adapt now to changing conditions, to new challenges, finding our way, just as every species must. The mountains teach us that survival requires flexibility, that thriving requires finding your niche, that beauty and function can coexist, that diversity is strength. 10,000 plant species, countless animals, millions of individual lives, all connected, all interdependent, all part of one vast living system that breathes and grows across these slopes. The Himalayas are not just geology, they are biology, ecology, a living entity, home to more than we can count, supporting more than we fully understand. And every species lost is a thread removed from the tapestry. Every habitat protected is an investment in resilience, in future, in the continuation of beauty. From the wild creatures, we turn now to another species that has made these mountains home, to humans, who have lived here for millennia, adapting, surviving, creating culture in the shadow of the peaks. Let us explore the human story of the Himalayas. We have journeyed through geology, through ice and water, through air and living things. Now, we come to ourselves, to humans who have called these mountains home, not for decades or centuries, but for thousands of years. Long before recorded history, before empires or nations, people lived among these peaks, learning to breathe the thin air, to navigate the steep slopes, to find sustenance where the land offers little, to create meaning in a landscape that dwarfs human scale. The Himalayas are not just nature, they are also culture, history, human adaptation, the story of how we learned to belong here. For millennia, these mountains were not barriers, but highways. Ancient trade routes crossed mountain passes, connecting civilizations that otherwise would never have met. Traders carried salt from Tibetan lakes, spices from Indian plains, silk from China, turquoise from Afghanistan. They walked for months, caravans of yaks and horses, crossing passes where the air burned in their lungs, where snow fell even in summer, where one wrong step meant death. But they kept walking, kept trading, kept connecting, because these routes brought wealth, brought ideas, brought stories from distant lands. The Silk Road, that legendary network of trade routes connecting east and west, passed through Himalayan regions. Merchants from Rome and Persia met with traders from China and India in mountain valleys where cultures mingled, languages mixed. Buddhism traveled from India to Tibet to China along these paths. Art styles merged, technologies spread. The mountains, seemingly so isolating, actually facilitated exchange. The high passes became meeting places. The difficulties of the journey made the connections more precious, more transformative. Trade goods flowed, but so did knowledge, philosophy, music, poetry. The Himalayas were crossroads of human civilization. But living permanently at these altitudes required more than determination. It required biological adaptation. High-altitude populations show genetic adaptations that helped them thrive where lowlanders would struggle. Consider the Tibetan people, who have lived on the high plateau for thousands of years, over 50 generations of selection, of survival at elevations where oxygen is scarce. Tibetan people have developed unique oxygen use efficiency. Their blood carries oxygen differently than lowlanders. Their bodies produce energy more efficiently. Their breathing remains easier even at altitudes where visitors gasp for air. Scientists have identified specific genes, variants that control red blood cell production, hemoglobin levels, blood vessel expansion. These genetic adaptations didn't happen overnight. They developed over countless generations, each one refining, improving the ability to live where the air is thin. This is evolution, happening in humans, observable, measurable, a testament to our species' remarkable adaptation. But adaptation isn't only biological, it's also cultural, practical, built into how people construct their lives. Traditional architecture in these seismically active mountains adapts to earthquakes. Houses built with flexible wood frames that can sway without collapsing.
walls of stone and mud that can crack without bringing down the entire structure, low centers of gravity, open courtyards that provide escape routes. These design principles, developed over generations of experience, of learning from disasters, of observing what survives and what doesn't, represent accumulated wisdom, engineering knowledge passed down through families, preserved in building traditions.
The steep slopes that characterize these mountains pose another challenge. Rain washes soil away easily. Gravity pulls everything downward. Farming on such terrain would seem impossible, but humans found a solution: terraced farming. By carving steps into the mountainside, creating level platforms held by stone walls, farmers prevent soil erosion while creating usable agricultural land. Water flows from one terrace to the next, irrigating crops without washing away the earth. The terraces are beautiful, geometric patterns flowing with the contours of the land, but they're also functional, brilliant engineering that allows rice, wheat, millet, vegetables to grow on slopes that would otherwise be useless for cultivation. For the people who live here, these mountains are not just landscape, they are sacred. The Himalayas hold profound religious significance in Hinduism and Buddhism especially, but also in Bon, Jainism, and local animist traditions. Mountains are seen as the dwelling places of gods, as bridges between earth and heaven, as sites of meditation and enlightenment. Pilgrims have walked these trails for thousands of years, seeking blessing, seeking wisdom, seeking proximity to the divine. One peak stands out even among these sacred giants: Mount Kailash. This mountain, not the highest but perhaps the most revered, is considered holy by 4 religions. Hindus see it as the home of Lord Shiva, Buddhists as the residence of Buddha Demchok, Jains as where their first leader achieved liberation, Bon practitioners as the seat of all spiritual power. Mount Kailash has never been climbed, not because it's technically impossible, but because it's considered too sacred to summit. Out of respect for countless believers, climbing permits have never been issued. The mountain stands, pristine, untouched, a symbol of the sacred, of limits we choose to honor, of respect for something greater than human achievement. Many monasteries dot these mountain landscapes, places of prayer and contemplation built in some of the most remote locations on Earth. And often, these monasteries are built at seismically safe locations. Monks and builders, through observation and tradition, learned to identify stable ground, places where earthquakes were less likely to collapse, ridges rather than valley bottoms, bedrock rather than loose soil. Modern seismology confirms many of these ancient sites were indeed chosen well. Their survival through centuries of earthquakes, testament to the builders' understanding, their careful observation of the land. Science and spirituality meeting in stone and timber, in structures that have weathered both storms and tremors. Life in the mountains follows rhythms dictated by nature. Cultural calendars align with seasonal changes. Planting festivals coincide with spring snowmelt. Harvest celebrations mark the end of the growing season. Winter festivals acknowledge the long, dark months ahead. These calendars aren't arbitrary, they're practical, connecting human activity to natural cycles, ensuring that work happens at the right time, that communities gather when labor allows, that spiritual observance reinforces social bonds during periods of rest. The year unfolds not by abstract dates, but by the greening of meadows, the ripening of crops, the first snow, the return of migratory birds. Traditional knowledge accumulated over generations guides weather prediction even today. Elders watch cloud formations, observe bird behavior, notice how smoke rises from cooking fires, feel the wind's direction and intensity. All these signs, interpreted through experience, help predict when rain will come, when storms might arrive, when it's safe to travel. This isn't superstition, it's empirical observation, pattern recognition refined over lifetimes, passed down through stories and teaching. A different kind of meteorology, one based on intimate familiarity with local conditions. Modern weather forecasts are often less accurate here, where terrain creates microclimates, where conditions change rapidly. Traditional knowledge remains valuable, relevant, trusted. Even conservation efforts draw on traditional practices. Sacred groves, areas set aside as holy, where trees cannot be cut, where hunting is forbidden, help preserve biodiversity. These groves weren't created for ecological reasons. They were spiritual sanctuaries, but the effect is the same. They protect species, maintain genetic diversity, serve as seed banks and refuges. Modern conservation science has learned from this, recognizing that protection doesn't always require fences and rangers. Sometimes, reverence accomplishes what regulations cannot. Spirituality and ecology serving the same end: preservation, respect for life, acknowledgement of interconnection. In recent decades, a new force has transformed these mountains: tourism. Thousands, now tens of thousands of visitors arrive each year. Trekkers seeking adventure, climbers pursuing summits, spiritual seekers following ancient pilgrimage routes, tourists wanting photographs of dramatic landscapes. Tourism impacts both economy and ecology. It brings money, jobs, opportunities for local communities. Guest houses, guide services, portering allow mountain people to earn cash income, to educate their children, to access goods and services. But it also brings pressure. Trails erode from constant use, forests are cut for firewood to heat lodges, waste accumulates, sacred sites become crowded, commercialized. The very beauty that attracts visitors can be degraded by their presence. The challenge is balance. Finding ways to share these mountains, to allow access and appreciation, while protecting what makes them worth visiting. Sustainable tourism, respectful tourism, tourism that gives back as much as it takes. As you rest here, breathing slowly, deeply, consider what these mountains represent. The Himalayas are a living interaction between Earth and humanity. The geology shapes where people can live. The climate determines what they can grow. The altitude affects their very biology. And in turn, humans shape the landscape, build on it, farm it, worship it, try to understand it. This interaction has been ongoing for thousands of years, each generation learning from the last, adapting to changes, finding new ways to thrive while maintaining connection to tradition, to place, to the sacred character of these peaks. We are not separate from these mountains. We are part of their story, just as they are part of ours. Every person who has walked these trails, carried goods across these passes, prayed at these shrines, planted crops on these terraces, watched storms gather over these peaks, has been shaped by the Himalayas and has shaped them in return. The relationship is mutual, reciprocal, ongoing. The genetic adaptations of Tibetan people, the terraced fields carved into mountainsides, the monasteries perched on cliffs, the trade routes connecting civilizations, the sacred groves protecting forests. All of these are evidence of human creativity, resilience, our ability to not just survive, but to create meaning, beauty, culture, even in the most challenging environments. These mountains teach us about our own capacity for adaptation, about how constraints can inspire innovation, about how hardship can forge strength, about how limitation can lead to wisdom. The people of the Himalayas didn't conquer these mountains. They learned to live with them, to respect them, to find their place within a system larger than themselves. Perhaps that is the deepest lesson these mountains offer. Not domination, but integration. Not control, but harmony. Not separation from nature, but recognition of our place within it. For thousands of years, humans and mountains have coexisted here. Through ice ages and warm periods, through empires rising and falling, through technological change and cultural evolution, the mountains remain, and humans remain, adapting, persisting, continuing. This is a relationship that honors both partners, humans respecting the power and sacredness of the mountains, mountains providing home and meaning to humans. May this relationship continue. May we learn from it. May we carry forward the wisdom that these heights, these peoples, these ancient stones and sacred peaks have to offer. And so, our journey through the Himalayas comes to a close. We have traveled from the deepest past to the living present, from the collision of continents to the breath of Tibetan pilgrims, from ice and stone to culture and spirit. The mountains stand as they have always stood, rising, breathing, changing, eternal and temporary at once, home to glaciers and snow leopards, to rivers and monsoons, to rhododendrons and red pandas, to traditions and adaptations, to the sacred and the scientific. Let yourself rest now in the knowledge of these 100 truths. Let them settle like snow, layer upon layer, building in you an appreciation for these magnificent peaks, for the forces that created them, for the life they sustain, for the wonder they inspire. May your sleep be as deep as Himalayan valleys, as peaceful as high mountain lakes, as restorative as spring snowmelt. The mountains will be there when you wake, patient, timeless, waiting, always waiting. Rest well, traveler. Rest in the shelter of the highest peaks on earth.